Okay, Chapter 3, we're going to talk a little bit about the time value of money. We're not going to get into a lot of details about the math, etc. We're going to look at the worksheet, do a couple of examples, and then some applications that are specifically geared towards financial planning. I'm sure you've heard of simple interest, where simple interest is essentially paid on the principal. So if you borrowed $100 with a 5% interest rate, you would earn 5% of $100 every year. The challenge with this is that it is not compounded. In the business world, all investments, all returns grow with respect to a term that's referred to as compound interest, or where we talk about interest earns interest. So the formula is, as you see a formula up here, this formula is an exponent. So it means that the interest that's earned every year is going to then be compounded and calculated and earn in earnings period after period after period. So in this case, again, this is all from the time value worksheet that's in the spreadsheet that you could download. And in here we see the what? You're going to invest $1,000. Now, you can follow along in with your worksheet. I suggest maybe you do that. Give a pause and fill in the blanks. You also have at your access some videos that you can click on to videos and answer and get a little bit more instruction, maybe a little bit more of a tutorial service, if you will, to try to understand how to solve some of these problems. For the worksheet, we have to tell the worksheet whether or not the money is being invested or whether the money is being received. If it's being invested, then that means it has to have a negative cash flow. So in this case, we're investing a negative $1,000. Interest rate's 10% for 2 years. We end up with $1,210. So how does that work out? Well, 10% of 1,000 is $100. You did that for 2 years. That's $200. But that second year, you made $100 at the end of the first year. That $100 also earned 10%. 10% of 100 is $10, and that's that extra $10 right there. So if you wanted to do for 10 years, what you would do is just change the time in years from 2 to 10, and you'd have $2,593.74. Again, what's 10 times 100? That's $1,000. So we have $1,000 investment. There should be $1,000 that's gathered from the investment of that 1,000, but we actually end up with another $593. That's from the 10% interest earned every year, earning interest time over time after time. So what about calculating maybe a fixed sum? There's something called the rule of 72, and it just gives us a quick little estimate of how long it takes for your money to double. So if you divide the interest into the number 72, it approximates how long it takes your money to double. So in this case, if you have 8% the interest, 8 into 72 is 9 years. Now if we calculate this using the spreadsheet, again, you're going to invest $1, negative 1. It's going to double, so it's going to grow to $2. 8% is the interest rate, and of course the time in years we have is going to be left blank because we're solving for that. And of course, if you look here to the right, the answer is 9.01 years. So we can see that it roughly takes 9 years for your money to double if you can invest at 8%. What about multiple compounding? That is, interest earning interest, but let's do it more than once a year, right? In this case, we're talking about quarterly compounding, right? Here's our $1,000 investment that we started with a while ago. Annual interest rate's 10%. We're going to invest for 2 years, but now we're going to compound it 4 times a year. So instead of 1 time a year, it'll be 4 times a year. And what we end up with, again, if you remember the previous answer, was $1,210. In this case, the same investment earns another $8.40. So we end up seeing what? That it grew faster, it grew larger, because we calculated interest more frequently, and every time you calculate interest, that interest is going to grow on a periodic basis from there on through the rest of the investment horizon. So you could do this with an interest rate. Here we have 10%. If you look at how it calculates out, if you will, for 2 years, annual would be 12.12%. Semi-annual is 12.15, 12.18 for future quarterly, and daily you'd end up with $1,221. So obviously you end up with a greater amount of earnings over the time frame if you compound more frequently. What that kind of brings to light is the differences in interest rates. When you talk to somebody about interest rates, they typically give you the nominal interest rate, this INOM, nominal. The nominal interest rate is the annual interest rate that you're told. If through this calculation here, we calculate what's referred to as the effective annual interest rate. So this is an annualized time value of money calculation of the earnings on an investment where we have more than one compounding period per year. So here we have the different effective interest rates. The annual rate, right, $1,000, 10% for 2 years. In this case, I have a picture of 365 days. Well, you earn $1,221, right, which is more than any of those amounts, so it must have a higher rate of return. So if you look at this, the annual rate goes from 10%, semi-annual is 10.25%, 10.38% is quarterly, and of course, in the end, this daily rate shows that the effective interest rate is 10.52%. So again, the importance of this is we have different investments, different types of investments or securities or projects, etc. They can have different compounding structure within them. And we want to be able to make a comparison on an even up type of analysis. And this effective interest rate allows us to organize that in a more comparable form. What about present value? In this case, we're told you're going to receive $15,000 in 5 years, and you can invest at 8%. So what is that $15,000 worth to you in today's money? Well, we need to plug in the data into our time value worksheet. 15,000 is the future value. You're going to get that in 5 years. You're told that 8% is the interest rate. And we'll keep the compounding frequency simple here and just say it's going to be 1 time a year. $15,000 in 5 years is the same as $10,208 today. They're equivalent numbers, but they're just in different time frames. So present value says if you knew you were going to receive $15,000, what do you think that would be worth to you in today's money? What would you be willing to pay for it? What's the most you'd be willing to pay for it? That's our $10,208 and in this case 75 cents. What about multiple compounding? If we change the quarterly thing, obviously it's going to change the answer. So we went from 10,208. If we compound quarterly, it's actually just $10,094. It's a smaller amount because we're compounding more frequently and we're bringing it back instead of moving it forward as we did in the previous example. What do we talk about? Payments, right? Certainly making payments are part of financial services. You can make investments in equal annual payments. Plus, when you are making loan payments, frequently the payments that you make are based on a monthly basis, and they're equal payments for a certain period of time. So in this case, you're going to invest $2,000 a year for 5 years at 10%. So we don't know future value or present value. We're going to solve for that, for future value. Interest rate's 10%. The time is 5. Where it says payment, PMT or A for annuity, negative $2,000 is the investment, because we're going to have a cash outflow every year. Compounding frequency equals 1, which makes it every year. So we would like to find out the future value. So what's the future value of the annuity? $12,210. So if you put away $2,000 a year for 5 years, that's $10,000. And of course, each year that's going to earn some money. So we're ultimately going to end up with another $210 for investment, or for earnings. What if you were going to receive $1,000 a year for 4 years? You can invest at 10%. So again, plugging in, the thing that we have to make that's primarily the thing we have to remember that's the difference here is we are now making or receiving $1,000. So the $1,000 payment now is positive. 10% is the interest. Time in years is 4. And we're going to do it per year. So the compounding frequency is 1. So the present value of these cash flows is $3,169. Again, we want to know the present value, and since we're talking about an annuity stream, that's PVA, present value of an annuity. We also have to talk about this distinction between when cash flows occur. When you invest, typically you invest today and move forward from there. What that requires us is have a definition of a type of an annuity. An annuity due is when the payment starts today rather than at the end of the period. And really this is it's not necessarily technical, but traditionally the financial calculators and the formulas for computers typically assume the cash flows happen at the end of the period because it matches the corporate cash flow concept. Cash flows always come at the end of the year. You don't know what they're going to be at the beginning of the year. But really, investments start at the beginning of the year. So if you took those last two examples, all we would need to do is answer this question. Is this an ordinary annuity? That is, do the cash flows happen at the end of the year? Or not? In this case, we're saying no. This is an annuity due, so we change this to an N. So the numbers obviously change. It's 13,431 is the future value. Oops, I'm sorry, didn't mean to do that. 13,431 is the future value. Push this button. We go back. 12,210 was the value with an ordinary annuity. So it grew to a bigger number if you do an annuity due. And it kind of makes sense because you start actually a whole year sooner and make the investments, and you have more time for it to grow. And of course, the annuity of a due of a present value is $4,169. Again, a different value because in this case, you actually have one less year as far as the cash flow way out there. So the number is going to ultimately be bigger because there's the cash flow comes to you. The first cash flow comes much sooner. There's a type of an annuity that's called a perpetuity. And a perpetuity, the definition is, it's an annuity, that is, it's an equal cash flow, but it's an equal cash flow that lasts forever. So if you were to get a $5 per year dividend, and that dividend was going to last to infinity, and you could earn 8% on your investments, what would the value of that perpetuity be? So the interest rate's 8%, the payment is $5. Now we can't really put in a time figure because there's no number to plug in for infinity. And it turns out we really don't need the number. Here's the formula, is just the payment, the cash flow, divided by whatever the interest is. So in this case, the present value of a perpetuity is $62.50. So you would be willing to pay $62.50 today so that you could get $5 a year to infinity. When we think about investing, especially if you think about retirement, one of the things that you're worried about is inflation. Maybe we would like to get our investment, in this case a perpetuity, we would like to have it grow and keep pace with inflation. So if you look at the table, it says growth of a perpetuity, you can put an interest rate in here. And typically we're going to put in here the inflation rate. So in this case we'll say if inflation's 4%, what would the value be of a perpetuity of $5 a year? Interest rate's 8%, but again, the payment grows by 4% a year. The present value of the perpetuity, remember, was $62.50, but now, since we're going to account for inflation and the cash flows are going to grow, this is actually worth more. It's actually worth $130. So we can kind of change the equal cash flow pattern, if you will, by talking about a constant growth rate. We can apply the exact same concept to an annuity. You're going to have a 10% interest rate for 4 years. The compounding frequency is 1, and the payment is going to be $1,000. So you're going to receive $1,000 a year, but we want that to grow by 4%. So the present value of a growing annuity is $3,349. Again, we want to change this equal cash flow stream to a constant growing cash flow stream where the constant growth happens to be inflation. We can also assume that we have unequal payments. And this really doesn't have a tremendous amount to do with personal finance, but it could have something to do with corporate finance. So in this case, just look, there are 10 cash flows that we think we're going to get in the future, and we know what those cash flows are. So this is on a worksheet called the time value mixed cash flows. So you list the cash flows. The one trick here is you have to remember that the cash flows happen at the end of the period. So they don't happen today, they happen at the end of the period at day 1 of the next period. So we have 10 cash flows, interest rates 8%. Now there's 2 numbers we can get from this. The present value of those cash flows, if you find the present value of each of these individuals and add them all up, is $69.65. The future value would say, if I reinvested each of these cash flows at 8%, what would I have at the end of the 10th year? And the answer is, you'd have $150.37. So we can look at individual cash flows, we can look at cash flows that are equal every period, and in this case, we can look at uneven cash flow streams. So here's an example we can talk about as far as an investment. We're going to invest $2,500 in a 10-year zero coupon bond. So we're going to assume that at maturity we're going to receive $10,000. The after-tax interest rate is 8%. So what we would like to do is talk about, well, essentially, what is the interest rate on this investment? If after taxes we can earn 8%, what is the interest on this particular bond? We're going to receive $10,000 at maturity. The present value is what we paid, $2,500, and it's a 10-year note, 10-year bond, and compounding frequency is twice per year. So the actual interest rate we would earn on this investment is 14.35%. Now, that's what we're going to earn. We have to figure out what our tax rate is. So let's say, if you were in a 25% tax bracket, again, I don't have that exact number on, let's use a different, easier number. A 20% tax bracket, essentially 20% of 14 is 2.8. So essentially we've got around 11% is the after-tax rate of this investment. And again, the after-tax interest rate on these investments, we would expect to get about 8%. So we're going to get a much higher return than what everything else is getting. So this might be a decent investment for us to make. Now we're going to go on to part 2.